Section 2.2 video part 5, and this will conclude this section. So let me remind you first of where we left off. Right at the end of the last video, I told you, I said, suppose we have the equation of a circle that looks like this. This is in center radius form. The center is -2, comma, +3, radius, square root of 16, which is 4. And I told you, I said, suppose we multiplied all of this out and got down to here. Now, is this and this the same stuff? Yes. It looks different, but it's the same stuff. I may have used this analogy with you, but I know I use it in my intermediate class, and so let me use this here. You know, it'd be like, the example I like using is if you're making a cake. If you make a cake and you take and you're putting all the ingredients in a bowl, you put the flour and the eggs and the milk or whatever goes in it, and you mix it all up, and you take a picture of that in the bowl. Then you pour it in the cake pan, you put it in the oven, you let it cook, and you bring it out and you take another picture. Now, question, do those two things look different? Absolutely. Does what come out of that oven look different than what you put in that oven? Completely different. But is it the same stuff? Yes, it's the same stuff. Well, that's the same idea here. This and this right here is the same stuff. The difference is what you see up here, this is in center radius form. This is not. So what I'm about to do first is show you how you can tell this is a circle, and then show you how you can tell it's not in center radius form. I did this in the last video. Remember, every circle has the x squared term and the y squared term and the equal and then a number. So you got the x squared term, the y squared term, and the equal. And you say, well, there's no number over here. It would be if you move that 3 to the other side. But what's extra in this problem that's not up here is that extra x and that extra y. So if you have the equation of a circle, you will have the x squared in it and you'll have the y squared. You have to have that every time. But if you have an extra x or an extra y or both, it's still a circle. It's just not in center radius form. Like right here, if I ask you to get the center and radius, you can't get the center and radius to this because it doesn't look like this right here. Does that line right there and that line right there look the same? No, they're not even close. Now, if you take these two things out, the center would be 0, 0. But it's because of those extra two variables there. All right, so let's take down this note. Here's the note. If we have the equation of a circle that is not in center radius form, we can put it in center radius form by completing the square on one or both variables. All right, so what I'm about to do is I'm about to show you how to take this problem and rewrite it like that so we can get the center and radius. Now, in order to do this, you have to know how to complete the square. Now, let's see, where did we learn how to complete the square? It was in section 1.4. Now, this is going to look a little different, but it's still the same steps to completing the square. All right, so write these instructions down to this problem. Here's the instructions. For the following, state the center and radius. For the following, state the center and radius. And you've got 4 or 5 of these like this on homework. All right, before I do this, how do I know it's a circle? Because the x is squared, because the y is squared. What messes up the center radius form? The extra x and the extra y. You have an extra letter on both of those. All right, so I can't tell you what the center is and what the radius is. I don't have a clue. All right, the note that you just took said complete the square. CTS, complete the square. Now, how do I know if I'm completing the square on the x's or the y's or both? I'll say this and then I'll say it again in a minute. If you have an extra x, you're going to complete the square on the x's. If you have an extra y, you're going to complete the square on the y's. If you have an extra x and y, you're going to complete the square on both of them. So that's what we're doing in this problem right here. All right, so here's what I'm going to do. I'm going to complete the square on the x's and the y's. All right, so let's do this. Let's put the x's beside each other. So let's rearrange the order and write it x squared plus 4x. And then let's put the y's beside each other. Y squared minus 6y. Now, if you'll remember in completing the square, one of the steps says move the constant to the other side, because there's no letter with it. So move that minus 3 to the other side. You do that by adding 3 to both sides. All right, we just said we're going to complete the square on the x's and complete the square on the y's. All right, so let's do this. Come down here and put the equal 3. Now, let's complete the square on the x's. Let me remind you of how we do this. Take half of 4. What's half of 4? 2. Square it. 2 squared is 4. And you add that. But whatever you do to one side, you have to come over and do to the other side. Let me do that again. Take half of 4, which is 2. Square it. 2 squared is 4. And add it to both sides. Now, let's complete the square on the y's. Plus, copy this down. All right. Take half of the 6. Half of 6 is 3. Square it. 3 squared is 9. And add that to both sides. Half of 6, which is 3. 3 squared is 9. And add that to both sides. Now, factor this and factor this one. X squared breaks up x and x. Sign to the same, both plus. I need 2 numbers that multiply to give me 4, that add to give me 4. It's 2 and 2. Now let's factor the y's. Y squared is y and y. Signs are the same, both negative. I need 2 numbers when you multiply them. You multiply to get 9, but you add to get 6. It's 3 and 3. Now let's simplify the right side. 3 plus 4 is 7. 7 plus 9 is 16. Now if you remember when we were completing the square, we wrote this as x plus 2 squared. We wrote this as y minus 3. squared equals 16. Now, this is in center radius form right there. Now, does that look very different than that right there? It sure does. The difference is now I can get the center, take the opposite of this, the opposite of that, and the radius is the square root of the number that's on the end, square root of 16, which is 4. So if you have an extra x and an extra y, you end up having to complete the square to put the circle in center radius form. So we have done, there's basically 3 things you need to be able to do from this section. If I give you the equation of a circle in center radius form, you ought to be able to get the center and radius just by looking at it and graph it. Plot the center, go to the right, to the left, up and down, whatever your radius is. That's the first thing you need to be able to do. Second thing you need to be able to do is if I give you the center and the radius, you need to be able to write out the equation of the circle. And then the last thing you need to be able to do is if I give you the equation of a circle that's not in center radius form, you need to be able to put it in center radius form by completing the square in order to get the center and radius. Okay, so this completes section 2.2, video 5, and also completes the section altogether.